Hi friends, this question is from test series 5. Subject name is OS, topic name is CPU scheduling, and it is of 1 mark. Let us see the question. Consider the following set of processes with the arrival times and the CPU burst times given in milliseconds. Process arrival time, burst time. For process P0, the arrival time is 0, burst time is 4. P1 1 2, P2 2 0.8, P3 3 6. In which order process completes execution using preemptive shortest remaining job scheduling? Option A, P2 P1 P0 P3. Option B, P0 P1 P2 P3. Option C, P2 P3 P0 P1. Option D, P0 P1 P3 P2. Before going to solve this problem, we have to know what is meant by shortest remaining job scheduling. In this, short-term scheduler always chooses the process that has the shortest remaining process time. When a new process joins the ready queue, the short-term scheduler compares the remaining time of executing process and the new process. If the new process has the least CPU burst time, the scheduler selects the job and connect to the CPU. Otherwise, it will continue the old process itself. Given process arrival time, burst time. For P0 0, and for P1 arrival time is 1, for P2 arrival time is 2, for P3 arrival time is 3. So since P0 is arrival time is 0, the CPU will use the process P0 at the time of 0, and the burst time for this P0 is 4. Before that, at the time of 1, that is nothing but P1 will attach it to the ready queue. So the burst time of P1 is less than the burst time of P0. So the CPU switches to the P1 at the time of 1. That is nothing but the process execution time of P0 is, now it is 3, and it will at the time of 1 P1 will execute. The execution time of P1 is 2. But at the time of 2, the process P2 is arriving to the ready queue. It will compare the burst time of process P1 and P2. The burst time of P0 is 0.8, which is less than P1. So the CPU will execute the P2. So at the time of 2, the process P2 will execute. The burst time for this one is 0.8. So 2 plus 0.8, which is nothing but 2.8. Here P1 execution 1 is completed. So one more time it has to be executed. So it was completed. So process P0 burst time is 0.8. Process P2 execution time is 0.8, so it was completed. So after that, the P1 at the time of 3 in the ready queue, process P3 is arrived, but the burst time for the process P3 is 6, which is more than these two processes, which is but P1 and P0. In this P1 and P0, P1 has less burst time than P0, so the CPU will execute the process P1, and the burst time for the process P1 is 1. So 2.8 plus 1, which is nothing but 3.8. So process P1 execution is also completed. So at last P0 and P3 are there. So we have to compare the burst time of P0 and P3, which is nothing but P0 burst time is less. So the CPU will execute the process P0, and the burst time for this is 3. So 3.8 plus 3, which is nothing but 6.8. After completion of P0, the CPU will execute process P3, which is nothing but the burst time for this one is 6. So 6 plus 6.8, which is nothing but 12.8. So the process P1 is completed at 3.8. P2 is completed at 2.8. P0 is completed at 6.8. P3 is completed at 12.8. So the completion order for this one is P2 is completed first time, so P2, next P1, next P0, next P3. So the order is P2, P1, P0, P3, which is nothing but option A. From this question, we learn what is meant by shortest remaining job scheduling and how to find out the order that process completes the execution using preemptive shortest remaining job scheduling. Thank you.